Hello everyone, this is Miss Lindsay. Today we're going to talk about section 2.3, drawing conclusions. In the first step of the 5 steps for drawing conclusions, you want to make sure that you memorize theorems, definitions, and postulates. Next, and most importantly, you want to look for keywords, symbols located in the given information. Again, in the given information, you want to find key words and symbols. So now think of all those theorems, definitions, or postulates that you know and we have used in class that involve those key words and symbols that we were talking about in the given information. Decide which of those theorems, definitions, or postulates allows you to draw a conclusion. Now when you draw a conclusion, this conclusion needs to relate directly from the given statements. So again, directly from the given statement. And then last but not least, you want to draw a conclusion and give a reason to justify the conclusion. Please pause and make sure that you have all these 5 steps written down before you continue. Let's look at our first example. First, we want to read the directions. Problems 1 through 4, we want to write a correct conclusion and a reason. So we do not need to actually do a 2-column proof here. So in our given information, we have line AB is perpendicular to line BC. 2 things we need to do. Mark our diagram as we normally would do. So we have a right angle there at angle ABC. And now we need to think about our key words, or in our case, key symbols. In our case here, the key symbol would be perpendicular. Since we already know, and we marked this on our diagram, that we'd have angle B would be a right angle, that would be a direct result from our given. So our conclusion could be that angle B is a right angle. The second part to this is we need to include a reason. This would be our if-then statement. Remember, our if comes from what we already know from our given. So if 2 lines are perpendicular, then they form a right angle. Okay. Moving on to number 2. Again, our given information here. Given angle DEF is complementary to angle HEF. So again, let's identify, in our case, a key word here, which would be complementary. Thinking about the definition of what complementary means, we would know that 2 angles, the sum of them would be 90 degrees, and in our case here they are adjacent angles, so we would be able to conclude that angle HED is a right angle. And our reason for this one would be if 2 angles are complementary and adjacent, then they form a right angle. Also, let's think about what the word complementary means. The definition of the complementary means complementary angles are 2 angles whose sum is 90 degrees, so in other words, a right angle, which differs slightly from what we were talking about in example 1. Perpendicular, 2 lines are perpendicular, then they form a right angle. Complementary angles do not have to be next to each other, so there would actually be one other option you could do for this problem. Let me switch colors. The other option is you could say the angle, I'm not sure why that color didn't show up, angle HED is equal to 90 degrees. Let me put a line there. And the reason for this would be if two angles are complementary, then their sum is 90 degrees. So in this problem, you could actually have two different answers, which would be direct relationship from the given. Unlike, I'm going to go back to problem 1, perpendicular, you could only specifically say angle B is a right angle based off of the definition of perpendicular. It does not say that they are 90 degrees. It says that they form a right angle. Moving on to example number 3. So here we have angle WXZ is congruent to angle YXZ. So again, let's just mark that on our diagram. What conclusion could we draw from that? Again, our key symbol in this case would be congruent. Excuse me. So let's think about some of our definitions that we know. We have two angles. They're connected by a segment XZ. So a direct relationship we could get from that would be to say that XZ bisects angle WXY. And our if-then statement would be if a segment divides an angle into two congruent angles, then it bisects the angle. Okay, let's go ahead and move on to the fourth example. Let me actually put something in this diagram that will help us a little bit. I'm going to label these angles as 1, 2, 3. At this point in time, I would like you to actually go ahead and pause, take a look at the given statement, look at your keywords and symbols, come up with a conclusion, and then go ahead and write your conclusion and if-then statement that supports that. Okay, so hopefully you notice that the key word is trisect. Then we can mark on our diagram that these three angles would then be congruent. So your conclusion would be that angle 1 is congruent to angle 2 is congruent to angle 3. And this would be because if two rays trisect, excuse me here, an angle, then they divide the angle into three congruent angles. And our fifth and final proof, or sorry, example, is we want to write two correct reasons. So we have two correct reasons and, conclusions and reasons. So two correct conclusions and reasons. So let's take a look at the given. So we have line WZ bisects segment VY. So again, keyword is bisect. Let's go ahead and mark that given information on our diagram. So as you can see, the direct relationship from there would be to say that VZ is congruent to ZY. So this would be our first conclusion. And our if-then statement would be if a line bisects a segment, then it divides the segment into two congruent segments. Okay. So now we have to think of a second conclusion that we can get from not only our given statement, but from what we just stated, stating that VZ, segment VZ would be congruent to segment ZY. So let's go ahead and take a look at our diagram over here. So when we look at our diagram, we can see that we have a segment that is divided into two congruent parts. Well, let's take a look at point Z. Another conclusion that we could get, since we know YZ, the segment or the line bisects VY, we can then go ahead and conclude that Z is the midpoint of segment VY, which is again direct relationship from what we just stated in our first conclusion. The if then statement would be if a point divides a segment into two congruent segments, then it is a midpoint. And this concludes the notes from section 2.3.